Hi guys, so again a short video, short demo about how to find using an experiment the coefficient of static friction and kinetic friction. So here I have a list and nothing special here. The weight is pulling down, the support force is pushing up, which is the normal force. So if you want to find the coefficient of static friction, you're gonna make an angle here. So it's going to become a inclined plane. And I'm going to have an angle here between the horizontal and the inclined plane. So I'm going to move it, lift it up a tiny bit. You see that static friction is holding it, so it doesn't slide. So it's in equilibrium along the inclined plane between static friction along the plane and the component of the weight along the plane. So that's going to be mg sine the angle here. So it doesn't move. And then I increase a tiny bit. So the component of the weight along the plane is increasing, but static friction is also increasing, pulling it up. I'm going to increase the angle until it starts to slide. So here we go. So if you find that angle here, then you can find the coefficient of the maximum static friction using that angle here. Okay, so I will show you the math, but you just take the tangent of that angle here, and that's going to be the static friction coefficient. To find the angle, you can use your, there is an app. You know, we don't expect very great resolution, but there is an app here on your phone that will compute the angle for you. And here it's about 15 degrees. I don't know if you can see, but it's about 15 degrees here. So the angle is about 15 degrees. So you take the tangent and you have the coefficient of friction. Coefficient of friction depends on the two material in contact here. So I have a metal here and it's another metal, but it's kind of rough. Now, to find the coefficient of kinetic friction. So it's a little bit different because you're going to expect to have a smaller, the coefficient of static friction, it's going to be smaller. And the way you do it is that you tap, tap, doesn't slide, tap, oh, it starts to slide. So that's going to be the angle that you're going to use for kinetic friction, right? So start from here, it doesn't slide, and you tap. When you see it start to slide, when you tap, that's going to be the angle that you want, right? And it's going to be it's going to be a smaller angle, so smaller tap, about here. So smaller angle, smaller coefficient of kinetic friction. So I'm gonna do a little bit of math, but not much because we do that in class. So remember that when it's flat, okay, so nothing happens. You just have weight pulling down, the normal force pushing up. As you increase this angle here, and that becomes an inclined plane, you're going to have a static friction force, which equals to the component of the weight along the inclined plane. And you increase the angle until it's about to slide, until it slides. That means that you have reached the maximum static friction. So when that happens, you're going to have that the component of the weight, the component of the weight along the vertical will be equals to the normal force. That's always true. But when it's about to slide here, you have that the maximum static friction equals the component of the weight along the inclined plane. Okay, and this is equals to the coefficient of static friction times the normal force. So you're gonna have mg sine equals the coefficient of static friction times the normal force mg cosine alpha cos. So you have the coefficient of static friction equals 5. And when it's sliding, then you can do the same computation, except that will be the kinetic coefficient. And you will find that the angle here will be smaller. And to do that, you increase the angle and tap until it starts to slide. So very easy demo to do. So just to show you that when you have an inclined plane, you're going to have a force here pulling down. Okay, and that's going to be mg sine the angle of the inclined plane mixed with the horizontal. And here you're going to have the friction. So if it's static friction, that means they are equal to each other. And then once you reach the maximum one, then you can say that this is equals to the coefficient times the normal force. Until you reach that maximum one, that means when it starts to slide, then you cannot, so here I have more friction, you cannot find the static friction is equals to mg sine, right? Only when it reached the maximum can we write down this equation. Once it starts to slide, so then we have kinetic friction. Kinetic friction will not change, right? So it's going to be kinetic friction equals to mu k times the normal, right? So it's a kinetic friction times the normal force, and then it does not change. So either it's equals to mg sine, so in that case it's going to slide at a constant speed, or it could be smaller. So if I had more weight or less more angle here, or less or more weight, you see that force here can increase. This one stays the same. This one is larger, so it's gonna speed up. And then I can apply Newton's second law, right? So mg sine minus the friction force equals ma. So it's gonna speed up. That acceleration will be smaller than 9.8, but still gonna speed up. My point is that kinetic friction does not change. Static friction will increase until you reach that maximum here. So I know that confusing sometimes for